So this is the 2015 Leave Insert Ordinary Level Paper 2, and we're looking at question number 5. The diagram shows the triangles BCD and ABD with some measurements given. So we can see the triangles over here, and you've got some angles on the sides. Part A1 says find the length of BC, correct to 2 decimal places. So these straight line brackets here mean the length of or the size of the line BC, correct to 2 decimal places. So the line BC, you can see here, that's this line. We're looking for that line, and that line is inside, or sorry, is part of this triangle here, triangle BCD. Okay, so we have, if we're looking at this triangle, we have an angle here, and we have the side opposite that, and then we have this angle, and we're looking for the side opposite that angle. So it's a non-right angle triangle, and we have 3 out of these 4 things, and we're looking for this one here. We'll call that X. So that should trigger in our minds the sine rule. So you should know that that's the sine rule. So from our tables book, we have for a triangle, a non-right angle triangle, we have a few formulas here from our tables book. And we can see the sine rule here. So the sine rule, A over sine A, so in other words one side over the sine of the angle opposite, will be equal to another side over the side of the angle opposite, the sine of the angle opposite it. So B will be opposite the small angle there. So we can just match our values up here to that. So our side B could be the 16, and the angle B there could be this angle, and then we can have our angle A, this one in blue, and we're looking for X. So that could be our angle A, and we're looking for X. So we're just going to put these then into the first part of the formula here, so with our B values there. And when you're using the sine rule, you only need 2 of the 3 parts, so you can just forget this here. So we're just going to set this up. So we've A over sine A, so that's the thing we're looking for, X over the sine of the angle opposite, with the sine of 42 degrees. And that's going to be equal to B over sine B, or 16 over sine of the angle opposite that, so 16 over the sine of 110 degrees. So the side we're looking for, X, which is the BC, so we decided to call BC X. Well, X will be equal to the fraction on the right, 16 over the sine of 110 degrees, multiplied by the sin 42. You multiply both sides by sin 42. That's what we're doing here. We're timesing this side by sin 42 degrees, and this side by sin 42 degrees. You can see here these ones cancel, that leaves the X, and then over here we have the right side. So when you put that right hand side, all of this here, just put that into your calculator, and you get 11.393, and on it goes like that. But we only need it correct to 2 decimal places. So our X value, which is our BC value, is going to be 11 point, to 2 decimal places. We look at the 3rd decimal. Does this 3 change the 9 in front? No. So it's just 11.39. And that's going to be meters. So that's part A1. Part 2 says find the area of the triangle BCD, correct to 2 decimal places. So the triangle BCD, that's BCD. So the same triangle again. I'm just going to redraw a sketch of it over here. B CD looks looks something like this. And we had 42 degrees here, we had 110 degrees there, then we had 16 meters here, and then we had the 11.39 meters that we just worked out there. Okay, and we want the area of this triangle. Okay, so in a non-right angle triangle we have a formula for area in our tables book, and that's this formula here. The area is a half AB sine C. So in other words, it's a half of the multiplication of two sides by the sine of the angle C between them. So you can see there, if you have A and B, the small a and small b, it's the sine of the big angle C, which is between them. So what you need is two sides and an angle between them. So at the moment here we have these two sides. So we need the angle between these two sides, which will be this angle here. So we need to know this size of this angle to plug these values into the formula here. So we know we have 42 degrees here and 110 degrees here. And we know that the three angles in a triangle add up to 180. So that's 42 plus 110 gives us 152. And when we take that from 180, that leaves us with 28 degrees. So we know that this angle here is going to be 28 degrees. So there are the values, the three blue values we can plug in here. So the area will be equal to a half times A and B, it doesn't matter which is which, so a half times 16 times 11.39 times the sine of the angle between them, so times the sine of the angle, 28 degrees. So when we put all of this into the calculator, we get 42.778, and on it goes. And again, we're rounding to two decimal places, so we're going to look at the third digit after the decimal. Does this 8 affect the 7 in front? Well, yes, it does. It's going to knock it up 1. So it's going to be 42.78, and its area, so that's going to be meters squared. So incidentally, you do need, when you're doing these calculations and the one previous, and this one here, you got to make sure that your calculator is set to degrees, because you're putting the sine of 42 degrees in. So make sure there's a small d at the top of your calculator for these calculations. Okay, so part B says find the length of the side AB, correct to two decimal places. So we want the length of the side AB. So if we go back up here, we can see that AB is part of the triangle ABD. In other words, there's AB, it's part of this triangle here. So the triangle ABD. So I'm going to draw that triangle. Well, before I draw it, what do we have? We have two sides in the triangle, 10 and 16. And we've no angles. Now, we should though be able to work out this angle here, because this is 63 and this is 42. So 63 and 42, if we add them, that's 105. So these three angles, 1, 2, 3, should add up to 180. They're angles in a straight line, so 180 take away the 105 leaves us 75 degrees for here. So that angle there is 75 degrees. So we can go back and draw our triangle now, ADB. Draw a sketch of it anyway. Sketch of ADB, so we had A here, D there, B there. And we had a 10 meter side here, a 16 meter side here, and we had the angle here in between, which was 75 degrees. Now, we were asked to find AB, so we were asked to find this length here, which we can call Y. We won't use X because we used X previously, so we're looking for Y. Okay, so if we have a situation here where we have two sides, we have the angle between them, and we're looking for the opposite angle, or the opposite side, the side opposite the angle, that should prompt us to think of the cosine rule. Because in the cosine rule, get rid of this now. In the cosine rule, you can see here, if you have the angle A and you have the sides, either side, that's C and B, well then you can find this A, B, C, BC there, and A. So you can see that this matches perfectly with our diagram. So we're going to use this cosine rule here to find A. This A side, which will be our value here that we're looking for, our side Y. So we're just going to apply this cosine rule now. So we have this side here, so we have y squared is equal to b squared, which in our case, our b is 16, so 16 squared, plus c squared, which is the 10 here, minus 2 multiplied by b by c. So b is again 16 by c, which is 10. And again, that's all done by the cosine, it's the cosine rule of the angle A, which is 75. So the cosine is 75 degrees. So, if y squared is equal to all of this, well, we can then say that y is equal to the square root of all of this. So the square root of 16 squared plus 10 squared minus twice 16 times 10 times the cosine of 75 degrees. And remember, it's the square root of all of that. And again, we want our answer to 2 decimal places. Let's not forget. So when we put this into our calculator, you can put the whole lot in. You should get a value of, and remember again, your calculator is set to degrees, 16.528, and on it goes. So to 2 decimal places, we look at the 8. Third digit after the decimal. Does this 8 affect the 2 in front? Yes, it does. So y is equal to 16.53. And that's going to be a length that's in meters. So that's the end of question number 5. That's the length of AB.